Hi, geometry students. It's me again, excited to talk about special right triangles. So we can have any old ordinary right triangle, right? But there's a couple of special ones. So if you notice up here, we've got 45, 45, 90s and 30, 60, 90s. Those guys are our special ones. We really like them. We care about them because honestly, they might make life a little bit easier. We don't have to necessarily do Pythag, or we might be able to solve them without knowing some of the special tricks and tips that we do later in the chapter. So let's start with the 45, 45, 90. So 45, 45, 90 refers to the angles. So we've got ourselves a 90-degree right angle, and then we've got ourselves these two congruent 45s, right? We also know from way back in whatever chapter it was, if we have two congruent angles, then their opposite sides are congruent. So we know that those two legs are equal. So here's the really nice thing. The length of the hypotenuse is the square root of 2 times the length of a leg, either leg, right? Because they're congruent. So let's say I said that this leg was 5 centimeters long. Well, then that means that this has to be 5, easy peasy. And that also means then this hypotenuse, without doing Pythag, without breaking down radicals, is 5 square roots of 2. So to get from a leg to a hypotenuse in a 45, 45, 90, you just multiply by a square root of 2. Easy. Done, right? Super shortcut. So what about if I want to go from a hypotenuse to a leg? What if I want to go in this direction? Oh, I should have written down here. Let's write this. Leg to hypotenuse. Multiply by a square root of 2. So hypotenuse to either leg. Well, we just do the opposite, right? If we multiply to get from a leg to a hypotenuse, we divide by a square root of 2. Going back to that radical section, we're going to need to talk about rationalizing a denominator because I wrote it as divide by a square root of 2, but we could also do over in fraction form. So let's do a quick example. Let's do, well, I think we could do a couple. Number 1 is super quick and painless. It says to find x. Notice somehow it has to tell me that I've got a 45, 45, 90. I could have actually, instead of typing 45 in here, I could have just done this, right? And then you would have known, oh, that's a 45, 45, 90 because those two angles are congruent. Remember our triangle sum theorem, the three angles add up to 180. Well, if I've got 90 taken and I have to split it equally between those two congruent angles, it's 45 and 45. So this one, I'm looking for x. X is on the hypotenuse. So I want to take my 4. So I'm going from the leg 4 to a hypotenuse. How do we get from a leg to a hypotenuse? We multiply by a square root of 2. So x is equal to 4 square roots of 2. Save me the Pythag. I could have done 4 squared plus 4 squared equals x squared and then solved from there. So quick and easy, multiply by a square root of 2. So number 2, it says to find a. Well, I've got myself a 45, 45, 90. My piece of information on number 2 is on a hypotenuse, right? So in this one, I'm going from a hypotenuse to either one of those legs. They're both A. So hypotenuse to leg, what do we do for that? We divide by a square root of 2. So we need to talk this one through. So I know that A is going to be equal to 8 divided by a square root of 2. But think back to our radical discussion. Am I ever going to be okay if you leave a square root in the denominator? You might think it's fine, but your teacher does not, right? So what do we have to do to get rid of a square root in the bottom? We multiply by that square root on the top and the bottom because anything over itself is 1. We're just changing the form. We're not changing the number. So on the top, we do 8 times the square root of 2 because remember, we just treat these as two separate problems. On the bottom, the square root of 2 times the square root of 2 is the square root of 4, which of course you know the square root of 4 is 2. Hopefully you've picked that up. So now I've got 8 square roots of 2 all over 2. I notice right here that I have a couple of things. I just ignore the radical. It's like having an x on there. Could you simplify an 8 over 2? That would simplify down to 4, right? And then tack that square root of 2 on there. 4 square roots of 2 is my final answer. You could say 4 square roots of 2 over 1. Remember that square root of 2 just sits up there. It doesn't do anything. It doesn't get simplified because there's no other radical. You can't cross over the radical box. So that's how we use 45, 45, 90 special rights. Let's talk about a word problem just so that you can see how I'm going to sneak those in as well. You're welcome. Find the diagonal of a square if the sides are 3 centimeters in length. Well, of course, the first thing you should do is draw it, right? So here's my fancy square drawing. If I mark all the sides congruent, you have to believe me. And each square is 3 centimeters, or each side is 3 centimeters, but it asks for the diagonal. So I'm going to draw a diagonal in there. Now, hopefully you're seeing that I just created 2 right triangles. If I took this out, you can for sure see it, right? There's a right triangle. I should have put my right angle box in there for my square initially. But I've got myself a right triangle. I just have to ignore the other part. Let me put that back so you can have it there. So I'm going to put that right angle. So basically, this is x. This diagonal here is what it wants me to find. Block out the other part if you want to block it out, or just draw it with the right triangle. So I know a leg, I know both legs, and x is on the hypotenuse. So how do I go from a leg to a hypotenuse? I multiply by a square root of 2. I like the multiplying by square root of 2, so we could say that the diagonal is equal to 3 times the square root of 2. And if we're going to be technical, we'll put centimeters on that. It looked complicated, but it turns out to not be all that bad. All right, so let's skip this one. Let's talk about our other very special kind of right triangle. So we've got 45, 45, 90s, and then we've got 30, 60, 90s. So remember, 30, 60, 90 refers to the angles. I've got 130 degree, 160, and then my right angle. The length of the hypotenuse is twice the length of the shorter leg, and the length of the longer leg is the square root of 3 times the length of the shorter leg. Both of those had shorter leg in there, right? So I want to tell you first of all that the short leg is the center of the universe. I call it SL for short leg. I know it's the short leg because it's across from the smallest angle. So if you're ever looking for what is the short leg, the center of the universe in a 30, 60, 90, look for your 30 degree, go opposite from that. So the easy one, the short leg to the hypotenuse, right? Everybody knows the hypotenuse is straight across from my right angle. Short leg to hypotenuse, SL to hypotenuse. Easy peasy, multiply by 2. Double it. That's the easy one. So what if I want to go from hypotenuse to short leg? I'd have to divide by 2 then, right? So hypotenuse to short leg would be divide by 2. So if the short leg was 5, my hypotenuse would be 10. If my hypotenuse was 100, my short leg would have to be 50, divide by 2. So that's the easy one. We like to start there. Over here, across from the 60 degree angle, double arc that, this is my longer leg. It's the leg of the triangle, but it's the longer of the 2. So this one is the one that, of course, we couldn't make everything easy. To get from the short leg to the long leg. Short leg to long leg. The rule tells us we multiply by the square root of 3. So I remember in a 30, 60, 90, there's 3 different sides. I multiply by a square root of 3. In a 45, 45, 90, there's two different sides, or some people say there's two congruent angles. So I multiply by a square root of 2. So that's how I remember it. I know it's dumb, but it works for me. So if I want to go from the short leg to the long leg, I multiply by a square root of 3. So if the short leg is 5, the long leg is 5 roots of 3. If I want to go the opposite direction, long leg to short leg, this is where the little bit of work comes in. I have to divide by a square root of 3, and I might have to rationalize the denominator like how we just did with example number 2. So this one, you could usually Pythag your way through it if you couldn't remember the rule, but sometimes you can't. Sometimes they only give you one piece of information. So if you remember nothing else, remember that the short leg and the hypotenuse are double or half. The short leg times 2 gives you the hypotenuse. Sometimes you just get the long leg, so you have to know what to do with that. So let's do an example or two. So number 1, it says find x and y. Well, the first thing I like to do is find the short leg. So here's my 30-degree angle. So over here, this 1/2 has to be the short leg. Hypotenuse is easy to find, right? Straight across from the right angle, which means that this y has to be the long leg. I know that because it's across from the 60-degree angle. Larger angle, larger side. So what do you want to start with first, the x or the y? There's no right answer. You can go whichever way you like. Let's start with this short leg to hypotenuse. Short leg to hypotenuse. This is the easy one. Multiply by 2. So hypotenuse x is equal to 1/2 times 2. So the hypotenuse is 1. You don't have to write out all that work. You're probably just going to do that on your calculator or in your head. But I want to make sure that you know what I'm talking about. So the other one, y. So going from the short leg to the long leg. Short leg to long leg says that you're going to multiply by a square root of 3. So I'm going to do 1/2 times a square root of 3. So you could write this two ways. I typically think of that as a square root of 3 over 1. So I'd say my final answer is a square root of 3 when I multiply the numerators over 2 when I multiply the denominators. So that one was nice, right? Because everything was the center of the universe, the short leg was given to you. What if you're not given the short leg, though? Short leg is the most important one. That's what we have to go through. Somebody always asks me, how do I go from the hypotenuse to the long leg? You have to go through the short leg. Even if you try to find a shortcut yourself, because you're one of those shortcut people, you end up finding the short leg along the way. So you have to work your way through the short leg no matter what. So let's go to, let's see, let's go to number 3. Find the altitude of an equilateral triangle with side lengths of 10. So of course, you are going to joyfully draw your best equilateral triangle, and even if it's horrible, mark all 3 sides as congruent. All 3 side lengths are 10 centimeters, but then it asks for an altitude. Think back to chapter 7, I think in section 7.5, right? We talked about altitudes. We also did that back in chapter 5, perhaps. Altitude goes from the vertex and forms a 90-degree on the opposite side. It doesn't have to be a perfect drawing. So this is what we're looking for. This is our x. Find the altitude of an equilateral triangle. Well, here's the thing. An equilateral triangle, how many degrees? We know they're all congruent, right? How many degrees is each angle? 60 degrees, right? 60, 60, and 60. So that means if, just like we did for the square with its diagonal, if I have an equilateral triangle, but I only show that half of it, if this angle down here is 60 degrees, this angle is a right, what does this angle up here have to be? We've sneakily got ourselves a 30, 60, 90. I know that this hypotenuse is 10 centimeters because when I ignore the other half of that triangle, that's the hypotenuse. It's straight across from that 90 degree that the altitude made. I also know that this bottom side down here where the altitudes hit is the short leg because it's straight across from the 30. So then I know that the altitude itself, whoops, let me just move this over, where our x is, this is going to be our long leg. So we're looking for the long leg, we're given the hypotenuse. So short leg is the center of the universe. I need to get from the short, or I need to get to the short leg so I can go to the hypotenuse. So let's look back. Hypotenuse to short leg. Hypotenuse to short leg. This was the one I like the best. Divide by 2. So what is the short leg? It's got to be 5, right? 10 divided by 2. So easy peasy, I got to that short leg. Now I need to go from the short leg to the long leg. Short leg to long leg. Now I can multiply by a square root of 3. So the altitude or the long leg, when I look at it as just a triangle, has to be equal to 5 times a square root of 3. I don't write it with the parentheses when I write my final answer, but you certainly could. So whenever you see those word problems, know when you draw an altitude for an equilateral triangle, you're going to have a half of it is going to be a 30, 60, 90. It's going to be one of our specials. If you've got a diagonal from a square, we know we're going to have a 45, 45, 90. So let's do one last example. Let's go over to number 5. Just because I feel like we should. Find the missing sides. I notice I've got a 90, I notice I've got a 30, so this one obviously then has to be 60, right? So I've got myself a special, right? I don't have enough information right here to do Pythag. I should have mentioned that on that last one. I have to know a special right. So the first thing I'm going to do on this 30, 60, 90 is I'm going to label my short leg, long leg, and hypotenuse. So QR is straight across from the right angle, right? So there's my hypotenuse. It says to just find the missing side, so I need to know what the hypotenuse is immediately, or at some point, I mean. Here's my 30-degree angle, so I know that side PQ has to be my short leg, the center of the universe, which means that PR, across from the 60-degree angle, is my long leg. So I'm given a long leg this time as my first piece of information. I have to go through my short leg. So long leg to short leg means what do you do when you do that? Look back at your notes. We divide by a square root of 3 different angles. So I'm going to take 5 square roots of 2. I'll just call this x. So x is equal to 5 square roots of 2 divided by a square root of 3. Is anybody highly intimidated by all these radicals? Don't be, because we can just do our work on the side. I don't actually even care about a square root of 2 on the top. I'm not going to turn it into a decimal because then I've rounded it. I'm going to keep everything in radical form, but the only thing I care about is the square root of 3 on the bottom. How do I get rid of a square root of 3 on the bottom? I multiply by a square root of 3 over a square root of 3. So numerator, 5 is on the outside. It can't combine with anything else. The square roots can multiply. Square root of 2 times square root of 3 gives me a square root of 6. And then on the bottom, a square root of 3 times a square root of 3 would be a square root of 9, right? Which the square root of 9 is actually 3. Can I simplify 5 over 3 if I just ignore the square root of 6? 5/3 cannot be simplified. There's my answer for the short leg. Short leg is 5 square roots of 6 over 3. It is not pretty. It's hard to put on a number line, but it is the length of side x, or short leg. So now that we've got this short leg to hypotenuse, this is the easy one, multiply by 2. So I'll call this one y. So y is equal to my short leg, 5 square roots of 6 over 3, multiply that by 2, And wouldn't it be easier to call that 2 over 1 so everything lines up? So 5 squared root of 6 times 2, so the outside stuff, the non-radical, 5 times 2 becomes 10. Stick the square root of 6 on it. 3 times 1 in the denominator is 3. So my short leg ends up being 5 square roots of 6 over 3. My hypotenuse ends up being 10 square roots of 6 over 3. Again, it's not pretty, but it's correct, and thankfully, it's complete. So we're going to do some practice with special rights. Practice those rules because they are shortcuts. They do make life a little bit easier for you. And we'll use these in later sections, but we'll also learn some tips and tricks and strategies if you don't have special rights, if you've got crazy ordinary rights. So that is it for section 8.3. Thanks for sticking around.